Hello, this is Walt DeVore. This piece of concrete employs innovations developed over a long period of time that makes it the most versatile, efficient building material that there can ever be. In the previous clip, you saw the voids being made by using styrofoam. Here, you see them having been made by an impression in the back. It depends upon what you're going to use the wall cavity for, and that will be coming up next. The embedded expanded steels overlap, and in that overlap area they're tack welded, which is a very simple, easy weld and can be done with a 115 volt inverter welder. So this joins the two wall faces together for a structural stability that's superior to any other arrangement in construction, with the faces of the wall being equivalent. It acts as a scaffold. The panels are aligned and sealed by a spline that fits into the perimeter slot around each panel. The spline, of course, goes in halfway, and then the adjacent panel swallows the other half. This chevron spline cross-section matches the slot so that it's a good tight seal, and it gives a little wiggle room for setting one panel upon the other. The primary function of the system is to serve as a finished wall and a stay-in-place form for cast-in-place concrete. This picture was the beginning of a house in British Columbia designed for maximum earthquake code, and it ended up requiring number 5 rebars on 16-inch centers vertically and horizontally. And you see the insulation is where it's supposed to be against the outside wall, and it's just a very efficient way to have your cast-in-place system without any forming expense. Having a flat level footing or slab to begin the first row on is most critical. If it's done well, then the job is easy. If it's not done well, then there's shimming and grinding, which can be a real pain in the neck. This piece of concrete, I believe, can really change the world. Looks pretty ordinary. It's 24 inches long, 16 inches high. It's one of many other sizes, not many sizes, just the minimum number of sizes to have amazing design versatility with it. And just to look at it, you don't see anything very special. But if you look around it, then all of a sudden this might blow your mind. I hope so. So we'll start off easy with just the side here. You see that it's got the slot that goes around all four sides. And what the slot is for is to take this little spline strip that goes right in the slot like that, just like that, and it sits halfway down in it, so, and it would be a continuous piece all the way around. So another piece can come sit down on top of it, and the two are mated together, aligned and sealed with this slot spline apparatus. And now the other mind-blowing part about this concrete is the backside here. Backside, you see these styrofoam inserts, and what they do is they change this block of concrete into actually a post and beam concrete wall panel. Post and beam because you have the vertical ribs and the top and bottom horizontal beams, so to speak, and they're joined together on the front with the monolithic web that joins them together. And what this accomplishes, and this is the magic part, it reduces the amount of concrete 40%, reduces the weight 40%, reduces the cement content 40%, and reduces the concrete cost 40%. And the 40% weight reduction keeps this from being a very heavy piece that I wouldn't be able to manipulate like this, just holding it here. It turns it into a piece that's only 37 pounds. And that 37 pounds is basically 14 pounds per square foot. So 14 pounds per square foot for a fireproof, ultraviolet proof, every kind of proof piece of exterior wall is just unbelievable. Nothing holds a candle to using that little amount of concrete. And the other magic part of this is these steels in the back of it. What they do is they're embedded in there, and it's the most powerful embedment with the least amount of steel that you can possibly have. And these steels are designed to overlap so that you have a wall panel on one side, a wall panel on the other side. You do a simple tack weld to join them together, and you have an unbelievably stable wall with a continuous open wall cavity down the center of it. And that wall cavity enables so much creativity, so much efficiency, that it's just only limited by your imagination and brilliance. And right off the bat, what that means is that you can fill this wall cavity with anything you want, whether it be structural concrete for a high-rise building, or plain dirt to be a insulating mass inside the wall, or conduits for hardwiring electronic devices, conduits for transmitting liquids anywhere, in airspace that can be misted for evaporative cooling. Just endless possibilities with this. It's something that's easy enough, simple enough that anybody can do it. There's only two requisites for this to work well. The first one is that the slab or footing that this starts off on, it's got to be perfectly flat. And perfectly flat concrete is a real work of art. It takes skill, but that skill is more easily developed now than ever before, using laser levels to confirm the flatness of your slab during screeding and finishing. And that's just a huge bonus to enable this system to work well. The other important component of this is precision molds so that these pieces go together perfectly. There's no monkeying around, there's no grinding, there's no shimming. The pieces just fit together fast and perfect. And the wall can actually be any thickness you want. You can have your 14 pound per square foot wall face, maintenance free forever, fireproof. Couldn't be any more economical. And my situation right now is I've got an inventory of molds for all the pieces of this system, and I need to get them in operation. I'm up here at 9,000 feet east of the Continental Divide. My body's wearing out from a lifetime of concrete work. We need some energy, some vision, some know-how, some cooperation, some teamwork, and just get this thing going. The quality of the structure that you can build for the minuscule cost that it would take, it's just phenomenal. And we're talking about concrete throughout. We're talking about horizontal slabs for roofs and floors that would be post-tensioned concrete, so the concrete would be squeezed together, never crack, be waterproof, use the absolute minimum amount of concrete. You can form structural cast-in-place beams and columns inside the wall cavity, especially at corners where there's doors and walls, to impart mega strength to the structure. Your concrete forming is basically free. I could ramble on forever about this, but I'm going to stop right now and put some more video together and see what you think. Architects out there, I really would like to know what you think this product would be worth. That would really go a long way in determining business model, margins, and all that. But for just the ordinary person, if you can get your hands on these molds, and I'm the only one that knows how to make these molds, this was taking me 30 years to get the mold to the point where I know it's the best that it can be. And the precision of the mold determines the value of the system. And I've been holding off all this time because I needed to keep making improvements, keep experimenting, trial and error, see what's wrong, work it to death, see what was good, see what wasn't good, and stay at it. I'm not very smart, I'm not very crafty, but all I am is persistent. I just have hung with this, and it is ready to go right now. I just need a network of people to come in, fill out the company, create a company to be sold or converted to stock or whatever. But it all starts by gaining your own experience, your own belief in the system by actually doing it. And up here on the mountain is the easiest, most sensible place to get that experience right now. and anybody that comes on board building you a house with this system would be the priority. So that's what's happening, man. Talk to you soon.